Welcome to GRE Math, tricks your high school teacher never taught you. I'm Gene, your GRE expert, and in this video, we're going to start exploring some problem-solving tricks that are going to help you infuse some points into your GRE Quant scores. Now, problem-solving is the biggest chunk of the overall GRE Quant pie. You'll see about 9 to 10 problem-solving questions per GRE Quant section. Problem-solving. You know, they give you a problem, you solve it, hence the name problem solving. Now, some of them are multiple choice, some of them are select all that apply, and in some problem solving questions, it's just you and the problem, mano a mano, where you have to just type in your answer into a little box. Those are often called numeric entry or short answer problems. So let's start getting into the fun stuff. The first problem we're going to look at here is a word problem. You're going to see quite a few of these come test day. We have a pet store where the ratio of dogs to cats on a certain day is 2 to 3. Then 12 more dogs get added, and then by the end of the day at the pet store, then we have a ratio of 4 to 3. Now the question wants to know, how many cats are there right now? Or as the cats might say, right, meow. Now, the way that your high school math teacher would probably have you approach this problem would be from a completely algebraic standpoint, where your high school math teacher would probably tell you to start setting up some proportions. Oh, I'll have dogs over cats, say we call it D over C, equals 2 over 3. Then set up another proportion where the number of dogs plus 12 over the number of cats equals 4 over 3. Then what your high school math teacher would probably have you do next would be to take each of those proportions, cross multiply, take one of those equations you have, isolate a variable, by combining like terms, then substitute into the other equation. This can be done. But if it strikes you as being kind of cumbersome, if it strikes you as being kind of bananas, B-A-N-A-N-A-S, it should. Forget all of that. We are not your high school math teachers. We want you to get as many points as possible on test day, as quickly as possible, and with as little pain as humanly possible. So let's talk about a little trick. When you are given a ratio and you don't know the actual quantities, consider taking this approach. Put in x's like so. You might know that song, All My Exes Live in Texas. We want all our x's to live within the ratio. So from this point forward, henceforth and forthwith, we now call the number of dogs at the beginning 2x and the number of cats at the beginning 3x. That reminds us that it's not that there were 2 dogs and 3 cats. It's a ratio like a fraction that has been reduced. We'll do the same thing with the ratio that we had with dogs and cats at the end of the day. We have 4x for dogs and 3x for cats. Now notice what quantity didn't change. The number of cats stayed the same throughout the entire problem. We had 3x cats at the beginning. We had 3x cats by the time we were done. So what about the quantity that did change? We started out with 2x dogs from the beginning. Then, after the outset, 12 more dogs were added, for a total then of 4x dogs. Well, we can get a short, sweet little equation cooking from that 2x plus 12 equals 4x. Subtract 2x from both sides, and we have 12 equals 2x. Divide both sides by 2, and x equals 6. Once you know what x is, you can answer anything they want from you in the problem. Well, what do they want from you here? We want to find the number of cats. The number of cats was represented by 3x. Now that we know what x is, we didn't know what it was before, so we just called our total of cats 3x. But now that we know that x is 6, that's 3 times 6, and you gotta be kidding me, as the cats might say. That's a total of 18 cats. Notice the math itself was fairly minimal with that trick. Little logic goes a long way. And in fact, once you found out what x was, you could have then plugged that into anything in the problem. How many dogs originally? How many dogs now? What's the sum of dogs and cats? Whatever. When you put in those x's into the ratios, once you find out what x is, you can answer anything that the problem wants from you. In this next problem, we're also going to talk about a little trick that's going to make short work out of what otherwise could be a really, really gruesome problem. We're told that we have a fraction, c minus a over c minus b equals 2. And what the problem wants from us is, what is the value of 5b minus 5a over c minus a? What your high school math teacher would probably have you do is take that original precondition of c minus a over c minus b equals 2, multiply both sides by the denominator of c minus b, distribute the 2 to the parentheses, combine like terms, and then manipulate it and manipulate it and manipulate it until hopefully you have something that resembles somehow 5b minus 5a over c minus a. There are two problems with such an approach. Number one, tick-tock, tick-tock. Time's a very precious commodity in GRE Quant. And the other problem with that approach is with every extra algebra step that you make, it's another opportunity to make a silly little error, which doesn't feel silly if it ends up costing you GRE points. So instead, let's talk about a little more of a logic-based approach, where the math itself is fairly minimal. We have a fraction that equals 2. Now, whenever you have a fraction that equals 2, what's the relationship between the numerator, that's the top part, and the denominator, that's the bottom part? Has to be twice as big, right? It could be 8 over 4, it could be 6 over 3, could even be 2 over 1. In fact, I really like 2 over 1 because those are very manageable numbers to work with. Typically, small positive whole numbers are the most manageable, as much as possible. So you want to use manageable numbers throughout GRE Quant. Tends to get you the right answers more quickly and less chance of error. So what we can do is we can pick our own numbers for A, B, and C to make the top part here equal to 2 and the bottom part equal to 1. We don't even have to pick numbers for A, B, and C all at once. We can do it piece by piece. How about we'll start with C? We get to use it twice, right? It shows up in both the top and on the bottom. So what if we make, for example, C equal to 4? Do we have to use 4? No, you don't have to. You just have to make sure that whatever numbers you use, make sure that that fraction does equal 2. Well, if we make C equal 4, and we want that numerator in that original precondition to equal 2, then what's our A going to become? 4 minus 2 is 2. So our A will become 2. And what about in that denominator? We want that denominator to equal 1. 4 minus 3 is 1. So our B is 3. Those numbers that we're about to use, the 4 for C and 2 for A and 3 for B, not only are they permissible because they satisfy this precondition, but they're also quite manageable to work with as well. So now we can take those numbers and just pop them into what the question's asking us, 5b minus 5a over c minus a. I think you'll find that once you plug in your numbers, it's going to start looking a lot more pleasant pretty darn quickly. 5b, that's 5 times 3, which is 15, minus 5a, that's 5 times 2, which is 10. Now we're cooking. Then in that denominator, we have c minus a, which with our numbers is 4 minus 2, or 2. We have 5 over 2. That simplified quite nicely, didn't it? 5 over 2, or 2.5, if you like decimals better. Whenever you're faced with a problem with unknown values, could be variables, could be number of elephants in the zoo, whatever, consider replacing them with your own numbers off the top of your head that you can plug into the original problem, turn the abstract into the concrete that way. It can get you more right answers more quickly than doing it your high school math teacher's way. Thanks again for joining me in this video. If you have any questions or concerns, please put them in the comments down here below. I'm here for you. And make sure you check out the other videos by subscribing to our channel. Onwards and upwards, GRE soldiers. I'm Gene. See you next time.